Hello, everyone. Welcome to the Christmas edition of the London Creative Coding Meetup. My name is Bernie. I'm replacing Dan this evening, who normally talks to you, but he is at home awaiting the results of a COVID test, which is probably going to be negative, but these times we live in. So Dan's given me a little bit of housekeeping and stuff to introduce. We've got two wonderful speakers for you here tonight, who I'm personally really looking forward to seeing. Before we get stuck into the program, I've got a few words that Dan's asked me to say. He's truly gutted that he can't be here. He's waiting at home. He's asked me to thank a bunch of people. He's asked me to thank myself, first on the list. Thank you, me, for filling in for Dan. The people from Huckletree here, Kieran, Kenny, Lucy, and those who helped us get this space. It's a wonderful space. If anyone's looking for co-working spaces, then this place looks awesome. Alessa from Code and Wonder, who helped us find this place. Our sponsors on the side there, Loop, a kind of real-time creative coding editor, and Salad Room, a app for, it's the easiest way to share content between devices. It's kind of like AirDrop for, but not just for Apple devices. When I say app, actually a website, because obviously if it was an app, you'd have to install it, and then it wouldn't be really easy. So we got two wonderful speakers, Steve and Seph. Thanks for you. I'll introduce you more in due course. And then finally, afterwards, we are heading to the pub around the corner. The Long Arm is basically just around the other side of the block to the way you came in. And Z and Anthony are going to be leading people there afterwards. So our first speaker, Steve Ruiz. Steve is a developer and interaction designer with a background in art, as in like he's a real artist. He like made actual pictures using liquid ink on paper made from trees with his real human hands, which is very exciting. But he's also a coder, and today he's going to talk about a project that combines his love of code with his love of art and ink, how to draw the perfect line. So everyone please give a warm welcome and round of applause to Steve Ruiz.
Cheers. I'm going to put this down for a second while I plug my stuff. Just curious, in case the microphone goes out, can you hear me? Cool. Yeah, thank you. I'm Steve, and I'm about to get plugged in, and that should go. So, tonight I'm going to be talking about this project. I'll show you it before we go. I brought my little stylus here, but don't necessarily need it. Works with the trackpad too. Hello! Right on. This is a nice, you know, if you've used drawing tools before or whatever, you're kind of used to seeing pressure sensitive, whatever lines or whatever. But this, my friends, this is SVG. This is vector stuff. It's not raster. How does it work? It's not in the spec, man. You can't do that in SVG. Well, short story is it's a long story. That's what we're going to talk about tonight. Let me start my thing. Actually, I get to do this. It's not the wrong. Here we go. Cool. So again, I'm Steve Ruiz. This is my Twitter handle, @SteveRuizOK. I encourage you to follow me because you get a lot of stuff like this. And by a lot, I mean like a lot of stuff like this. If you're interested in little Twitter deep dive threads, then you would love. That's where I put it. I put a lot of it out there. Currently, I'm working on something called tealdraw.com, or tealdraw, kind of a engine for drawing tools, spatial UIs, things like that. It looks a little like this. It's free. You can do like multiplayer rooms. If you like Excalidraw, it's a lot like Excalidraw. So yeah, tonight we're going to be talking about Perfect Freehand, which is a open source library for drawing the perfect freehand pressure-sensitive line. And the story of how it works is kind of like that. It works like that. Let's talk more about how exactly that works. So first off, if you do have your phones and you want to try it out yourself, you can snap that VR QR code, and that'll take you to the example website, which should show you a big menu of all the options. You can close that, and then you can just draw with your finger. If I did my job right, it'll be the best virtual pressure, whatever experience that you've had drawing on your phone. You may ask yourself, how does that work? And yeah, in order to talk about perfect freehand, I have to talk about a couple of other projects. One is called Telestrator, one is called Globs, and even TealDraw itself to some degree. But first, I need to talk about perfect arrows. And this is how I kind of got into solving these types of problems to begin with. I was working on a website called State Designer for designing state charts, I suppose. And the way this would work is that you have a visualization of the state chart that you're designing over there, and then you have a UI at the same time. So in this case, you would start drawing, it would change the state if you've worked with state machines. But this is something that you could also be driving through interactions with this chart. And as part of that, I wanted basically this kind of interaction where if I was hovering over selected eraser, obviously if I clicked on that, it would take me to the eraser state. It would transition to that state. And so I would want an arrow that kind of pointed at that state, say hey, if you click me, this is where I go. And so I got really into arrows because I didn't know where these arrows were going to be. I just needed to say I have two rectangles, show me a good looking arrow that connects the two. And that turned into a hugely complex problem because what if the arrows are overlapping? The rectangles are overlapping, or what if they're far away or close? And so I kind of did this in public of trying to figure out this algorithm for creating arrows. And it ended up being this weird flexible box type thing where it would kind of compress and the arrows would get wider. So it would look kind of like this. And you put an arrowhead on the end of it, and now you have your arrow. It gets a little bit more complicated as things get closer together or closer to zero, or 90-degree increments. Certainly you would want to round the corners of that rectangle, and it got hard. I had to learn a lot of vector math and a lot of intersections and all this stuff. But at the end of it, I had a library called Perfect Arrows that would do the job. It kind of looks weird when you animate it like this. But you can give it two boxes of two bounding boxes, and it'll give you a pretty good arrow that will, or at least the information that you need to draw that arrow between the two. And this was my introduction to solving these type of trigonometry-ish problems that I really didn't know how to do before. And of course, this is the result. I had my nice graph, and I had arrows that would go from one thing to another, and even if you changed it and whatever flexboxed it, more narrowly, the arrows would always be correct, and they would always look pretty good. And so that was Perfect Arrows. And yeah, I think it has 2,000 stars or more than 2,000 stars on GitHub. It's, basically if you need something with arrows, you should probably use Perfect Arrows. Why not? You're not going to write this yourself. Come on. And yeah, here's another little GIF. If you decide to sponsor me on GitHub, by the way, for the out of kindness, but also you get access to this folder of all these GIFs that I've been posting on Twitter. It's 2 gigabytes worth of fucking arrow GIFs and stuff like that. So anyway, I had no shortage of resources for this talk. So yes, I did the arrows thing, but I also learned a lot about the sort of math involved in visual design tools. And okay, how do I do intersections against curves and all that stuff? Extremely satisfying to work on, extremely satisfying to debug, because it would all look like this. The next problem that I had was I wanted to be able to draw on my screen. I was doing like video tutorials, and I wanted, like, if you've ever watched, I don't know if they do this in the UK. In the US, with football or sports or whatever, they're like drawing on top of the screen and saying like, this guy is gonna go over here, or whatever like that. That is a technology called a telestrator. That's the word for it. And I wanted to do that while streaming. I wanted to be like, you know, whatever, like, look at this part of the screen over here, and then whatever. And I didn't want to do that in post. I wanted to do that live. So I did it. I made this like little Electron app that let me do that in like an afternoon. And then I had the thought of like, well, hey, I'm using like a stylus like this. Like, how do I make it so that the line is like pressure sensitive? Because my stylus can do pressure, so how do I do pressure sensitive line? And that is how I ended up spending the next 9 months working on, on how do you do pressure sensitive line. And it works a little bit like this. So I'm going to talk you through the algorithm. When you record a user's mouse position or something like that, right? Pretty much 60 times a second as you're clicking and dragging, the browser is saying, hey, the mouse moved. Here's where it is. And then, hey, the mouse moved, here's where it is. And so you can collect all that information, and now you have like a collection of like raw points. And that's essentially like everywhere that the browser saw that the mouse was, or the pointer or whatever it was, in order at all those different times. That's pretty noisy information. In fact, this is cleaned up. So there is a step there, even before we get to this step, where you have to like remove the noise from the line. Essentially, like you average each point with the previous point by a certain amount, and that kind of like removes the noise. Next, you need to decide, well, where were those things pointed? So you say like, okay, well, this is the previous point, here's the next point, take that's like the direction or the vector, normalize that vector to divide it by its length, and then that's the point. So now if we want to make points out to either side, imagine a row of people all with their arms out like this. I was going to do like an audience like thing like this, but I'm not going to do that. So now we have kind of like the information that we need in order to find these kind of like winding points, winding along the left, winding back around the right side. So we'll say blue is left and orange is right, or something like that. Then we have to take the idea of like pressure. So there's two ways to do pressure. One is to actually get pressure from the input device. So like, you know, whatever, if I'm drawing with a stylus or an Apple Pencil, that'll actually tell the browser like, hey, he pushed, you know, 1 for real hard or 0 for not very hard at all. And that's one way to do it. The other way to do it is to simulate that pressure based on the distance between the points. You can also do it with time, but I think time is a little tricky, which is probably the understatement of my life. But yeah, time is a little bit tricky. So space is easier. Either way, once you know the pressure, then basically the arm audience interaction thing is like, if you're close to the person in front of you, then your arms go out farther. If you're far away from the person in front of you, then your arms kind of go in like this. And that way, you can do what is starting to look like a stroke, like a pen stroke. Now you have to wind. You wind, well, you could, whatever path you choose. I wind to go down the left side and then back the right side. And that gives you a shape. And you just fill that shape in, and you're almost to a perfect freehand line. This is how, like, if you have a video game that involves like a racetrack, it's kind of the same thing. So you have different points, vectors, push them out by the width of the track, and just wind around in order to get your shapes. However, this as good as this looks and as whatever, it's not perfect. You could probably see a couple of problems. Definitely the corners. It's still a little bit noisy. It has some ways to go. So for example, doing it this way produces more information than you actually want. is that since you want to draw a curve that connects all the points, you know, like when you wind around left side, back to the right side, curves do better with curves do better with less information than they do with more information. Unless you're around corners, then they do better with more information, and they do worse with less information. So you needed some way, the algorithm needed some way to like dial in or out the amount of information that it has to work with. So we can see that here. These are all the points that were actually generated, and then here I'm like simplifying them. I'm not curving them so that you can kind of see what's going on. So I called this smoothing. It's the idea that you could like remove the amount of information, basically like what's the shortest amount of distance between those points that they could be before you decide not to show them. But that's only one way of like reducing the information. The other way of reducing the information is by something that I called streamlining, which I think that's what you call it, but I don't really know for sure. And this is, as I said before, you kind of remove noise by averaging points to like the previous point. And you can imagine like, well, the more that you average those points back towards the previous point, like the more they'll all kind of be similar to each other. And a little bit of that is actually like correct. A lot of that is very wrong. But you can see here, this is with like no streamlining, and then that's with more, and there's kind of a sweet spot in between. And if you take it too far, then you can kind of create these weird like, you know, this is the original one, and then this is the super streamlined one. Cool. So now I had a couple of like knobs to turn, right? I like had this smoothing idea, this streamlining idea. I could calculate pressure. I could adjust the way that the velocity is simulated. And so now I had an algorithm for, you know, pressure sensitive freehand lines. And so I was like, good, I'm done, perfect. Release on NPM, do a little bit of Twitter hype, go to bed, everything's good. This was after a couple of weeks, and I posted, you know, the whole kind of journey on Twitter. But there were so many edge cases left to solve. What about corners? Corners are super hard because you can think of like the direction, it's like going like this is all good, and then suddenly it's like totally the opposite direction. And if we do the winding thing where I'm going up on the left, you get these weird things, these like kind of artifacts at the corners. And so that meant we needed some way to do like caps, some way to detect a sharp corner. And then, like I said, like it does better if you have more information around corners. Basically add in all those lines around the corner artificially. So switch algorithms if it's a sharp corner. And that works pretty well. The other one was tapering. And I love tapering because it looks so cool. So the idea that there would be, again, that kind of like that pressure arms audience interaction that I talked about before. If you were at the start of the line or at the end of the line, then there would be some sort of like limit to what that pressure could be, or some sort of easing function applied to that pressure. And what's fun is that it's like, as you're drawing, you're defining the end of the line as you're doing it. So when you work with this, and maybe if you scan that QR code, you can kind of play around with that. It feels really cool, like because it's like the line is like appearing behind you. It's great. So once I did caps and once I did tapering, then there was also the idea of like flat caps. So this has like a flat cap at the end rather than a round cap. Yeah, there was a couple more, but in general, that was perfect freehand, and that's how it worked. And it was kind of like a naive algorithm that I just brute force made worked and like solved all these little edge cases one at a time. But the result is like really good. It's really fast. People started using it in their apps. It has a pretty good adoption. I think it's one of those things where like, if you want if you want a line like this in your product, I don't know. There has to be a pretty good excuse not to use perfect freehand at this point, because like to do normal like lines where you're just taking those points and connecting them, or maybe simplifying them and connecting them, just doesn't look very good. If you've ever made a drawing app, you probably know what I'm talking about. However, the story doesn't necessarily end there, and I should probably check the time just so I don't go over. I'm good until what, like 45? Yeah, cool. Because it keeps going. Definitely keeps going. One of the things that I made after this was like a Figma plugin, so that you could take your pencil tool, the most useless tool in Figma, a little pencil tool. It's gotten a little bit of attention now because of FigJam, which is good. It deserves it. But it's a pretty rough tool for defining these type of paths. But it would take that information and convert it into, or run it through perfect freehand, and it's just points in, points out. And so now there's a Figma plugin, which is pretty cool. You could also use that Figma plugin to run any path data through it. So not necessarily path data that you made by hand, but like icons. So this is taking the feather icon set by Colbemis and running it through perfect freehand, and it kind of gives you a hand-drawn looking icon set like for free, which I haven't seen anyone use this, but it's pretty good. Some icon sets look better than others, but it's pretty choice. Next, I implemented it in Excalibur, which is if you don't know Excalibur, it's also a wonderful app. And this just like replaced their pen tool that was fine, but it just didn't feel like a pen. Which like I don't know if like as a software user, as a person who this is like the worst. Like my estimation of the pencil tool was like so low, like already. Like I never expected anything out of that. However, we're doing more things that involve annotations and hand drawing and stuff like that. And so like, yeah, maybe it's time. Maybe now is the time for the pencil tool and the pen tool to really come into its own. This is probably the product that you saw, or the new demo, which is, yeah, rebuilt and has a lot of knobs to turn, including like caps and tapering and things like that. But I've seen some pretty wild stuff made with the algorithm. I also did like a Flutter implementation, which is this was my first time using Flutter or Dart or any of that. But again, it's a pretty simple algorithm. It's just like as with all like tight algorithms, like every little bit is important. And since it's a visual algorithm, if you get anything wrong, you see it immediately. It's just like, whoa, what's that? I also did a Pico 8 implementation of this. So this is in Lua. And I had never really thought about the performance limitations of perfect freehand until I did this. And I was like, oh, all that sloppy garbage collected, stuff that I didn't care about with JavaScript suddenly mattered a lot more when working with Pico 8. So much so that I started doing a second version of it. And I was like, okay, well, what is the actual, like, how far can I take this before the performance really hits? And one thing to know is that it's recreating the entire path every frame. So there's no like memory for this. It has no sense of like, oh, there used to be these 3 points, now there's a 4th point, so that's the only point that I have to solve. It's not piecewise at all like that. It's solving the entire thing every time. Luckily, it's pretty fast. Like it's, in many cases, the slowdown that you're seeing here is more due to SVG than it is to perfect freehand. One of the benefits of working with the web is that rendering usually kills you before anything else. So you can kind of be a little bit sloppy because, like, by the time you would notice it, the browser is going to be your bigger problem. But that said, I got up to like 2,500 individual points before before it started complaining at me. But that did lead me to a second version, which was more persistent and used less memory, and is still in the works, and might be a pro version at some point. But the GIFs are pretty good, like, very satisfying. This actually is persistent, so like those little points aren't being recreated from scratch. It's like the same point in memory that's being moved. I don't even know what this is. Normal's trying to detect edges, probably. At the same time, I had like a nice little algorithm, and I could take this wherever I wanted it. So this is a raster version that is being rendered in, I forget, 3JS or something like that. Did a little bit more playing around with like a brush engine. You know, can I introduce jitter or these other things that I might be used to from something like Procreate? Yeah, here's jitter again. This is no longer SVG. This is in Canvas. I was just looking for different ways of making this thing better, experimenting, kind of casting a pretty wide net. Then I was talking to another developer who was like, yeah, I can't tell you how we do our freehand line. This is the developer of an app named GoodNotes, which has a really, really good line. And I was like, how do you do your line, man? Like, just tell me. Just tell me, how do you do your line? He's like, oh, we use circles. And that's all he would tell me. And so that sent me into another like 2 weeks of like, how? Like, what is circles? Circles. And I tried using this, and then finally, like, this is the idea that I had, is that you take the outer tangents of circles, right, and connect those, and then somehow curve the points where those outer tangents touch the circle. The visual probably explains better than my high school geometry attempt of communicating it. Then I learned about globs. Oh my God. Globs. This is this was introduced by a man named Andrew Glasner, who like has been involved in computer graphics for forever. I think like the first version of like Graphic Gems was like edited by Andrew Glasner. And he was like, hey, I have this idea for a little new primitive. Like, you guys like lines and circles and stuff? Well, here's a glob. It's two circles. They're connected by curves that touch at outer tangents. Very similar to what we were working on in, or thinking about with Perfect Freehand. And so began yeah, I'm still good on time. A brief journey into globs, which consumed me for several months. I ended up making an entire editor for globs, like an entire like piece of software on the web. It's globs.design, by the way. You could go to it. It's still there. And the fun part about this is that since this was a new like design primitive, like it involved rethinking a design tool where the only thing you had to work with was globs. And I really, really wanted to figure out, like, is this possible to be, like, to use with Perfect Freehand or some version of Perfect Freehand? Could this be used for freehand text? And so in order to do that, I had to kind of learn all about globs, which as a designer was fascinating, and as a developer was fascinating. And as someone who likes the word globs was fascinating to work on. And so discovering all the ways that you would want to, all the things that you would want to do with this primitive called the glob. Sad part is I never got it to work with freehand. I'll show you in a second. It's really fun to work on, by the way. If you ever have a little experimental time, perhaps over the holidays, and want to make a letter form using globs. The typography community was all over this and be like, look, this is theory. You need to do this what do you call it? Parametric letter form design, whatever. Anyway, so I worked on globs for a little while. I tried to make it work. I made beautiful things with globs. I got really excited about globs. I made an entire editor around globs. I talked to my wife about globs. I made cool experiments on globs, and I got a bunch of Twitter followers by just spamming GIFs like these all over the place. But I never got it to work. I just learned a lot about how design tools work. This was fun, because you have to invert the globs. Notice that I'm using left blue, right orange again here. Notice how the left has to become the right when you switch, like follow a point. It's like, whatever, globs. Sponsor me, you get all these gifts, and yeah. Okay, hold on a second. Yeah, this is as close as I got to ever using it for freehand stuff, and that's not very close at all. But I did learn a lot along the way. This shouldn't be here. Yeah, like I said, along the way I kind of built an editor, and then I was like, well, I might as well have a code editor in the glob editor. So I built a code editor in the glob editor. Then built an entire product around the glob editor with the code editor in it, so you could share your globs. Then I thought maybe, okay, well, back to the drawing board. I really like the idea of having a programmable editor for my, work on perfect freehand, so I'm just going to build a new website with a programmable editor so I can do the perfect freehand thing. And that turned into Teal Draw, which I'm still working on. It went from a nice, cool programmable editor that would probably have been perfect for NFTs if they had existed a couple months before they all became the big thing. But yeah, now it just turned into like general design tool stuff. And now I built Teal Draw, which turned into a pretty cool project on its own right. And that's like the project that I'm working on and like fundraising for at the moment, because this type of stuff is pretty interesting. It turns out arrows, freehand lines, shapes that weren't made by a freehand line, but they look like they were because I have an algorithm that I can just say, like, make this look like it was freehand. All the good building blocks of a modern diagramming design tool and more. And I think that may be the talk. It is the talk. Thank you. Later, if you want to play with this, just come find me. We'll draw it together. Sorry? Oh, wait, we have a question, Mike?
Yeah, hang on.
Left to right? Yeah, it goes wherever, man.
So anyone has a question? Bring the question back to you.
Hi, most of your displays, whatever display, is from left to right. So have you ever tried from right to left, drawing stuff like that? I mean, like the lines which you're drawing, is everything from left?
Yeah, no, I mean, you
works,
can,
right?
yeah, you can
I just
definitely,
want
I
to know
mean,
it works.
it goes both ways. Unfortunately, I don't really know how to,
Okay.
I can't really write right to left. All the, but I certainly can draw right to left, and it's fine. I don't think the directionality impacts anything. Yeah, it's just about vector and dot products and all that fun geometry stuff.
Hi, thank you for the talk. That was really nice.
Thank you.
You mentioned time-based pressure, and that was tricky. So have you tried it, and what was the main problem with it?
Let me try and remember exactly. The problem with time-based pressure is that you have to remember, or you have to store the time, basically. So that has to become part of your data model. The data model, like the data required for these lines is already pretty big. And because again, normally when you go into an app like Figma and you draw a line, they do a simplification step. They say, okay, these are all the input points, but we don't really need all those, so we're going to simplify that. We're going to do some whatever path simplification algorithm so that we only store the points that we need. However, for teal draw, we have to store all of them. Or not teal draw, for perfect freehand, we have to store all of them because we're using that data to calculate velocity and pressure and all that. We can't just store the outline, otherwise you would never be able to change the, you wouldn't be able to like do this, right? Like we need all the information there. So the data was already pretty big to begin with. And the problem with time is that now you have just like an extra thing. And if you're using time and actual input pressure, then now you have like 2 extra things. So it was easier just to store the position and then the pressure if it's there, like the input pressure. But yeah, I'm trying to remember the actual like programmatic complexity, but I can't remember it. All I remember thinking is this, like, screw this, I'm gonna just use distance.
Thank you.
Really good talk, thank you.
Thank you.
Do you have any design background?
Yeah, I do.
With the, sorry, go ahead.
Yeah, I mean, I got into tech as a designer. All my first jobs were design roles. I don't think I've ever actually worked outside of a design organization at any company. But I was always the like designer with a little bit of technical skill. I could do the prototypes. That was sort of my specialty. So yeah, art and design and moving into development and engineering and whatever. Oh yeah, I'll face the camera.
So the question on YouTube from Harry Miller says, how many months did you work on Teal Draw?
On Teal Draw, I think I started what would become Teal Draw maybe in like March of this year, maybe a little bit earlier. It was kind of a blend between globs and then into, I started Teal Draw because I thought I've made like several sandbox kind of environments for, you know, for perfect freehand or for globs. And I was like, I'll probably continue making these type of apps in the future. So I probably want a kind of a more generic or agnostic, primitive agnostic design environment that I could then extend into whatever I was working on, which that's what Teal Draw became. Because again, like globs worked, but it would only worked for globs. Like you couldn't do anything else with it. So with Teal Draw, I was like, I want to still have a programmable environment, but I wanted to just work with anything. And that turned into more of like a product of its own, which is very different, but in many ways the same. Yeah, so about March till now. I started working full time on it in July, so that's right. Thank you.
Yeah, thank you, Steve, for the interesting talk. I was wondering, do you think that, like, I was wondering about the application of the, like, all the libraries that you mentioned. So do you think that will be, like, how, you also mentioned good notes, so how will it be different, like, or do you think that we will have like applications out of the designer's world, or like?
Yeah, so I made, like, perfect freehand isn't a product per se. I mean, it is a library for a very specific thing. And you can do kind of interesting things with it, but it's not a product in itself. It's being used in other products. Teal Draw is a little different. It's kind of both a whiteboarding tool and then like the engine for other people who want to make these type of apps, spatial UI type of things. So that I'm still working on exactly productizing that, but that's the idea. It's more of like a infrastructure for, it's like Mapbox for design tools. Yeah. But yeah, the perfect freehand is more narrow.
Sorry, just a quick follow-up.
Sure.
Is good notes and like apps like that already have that? Like you mentioned, you asked someone to good notes, so it's like, do they already have this kind of library and they didn't make it open source? There
are no open source. Well, this is like, let me show you the the state of the art for open source like freehand lines like this. This is signature.js, and what's interesting here is it's not terrible. It's okay. It's fine, whatever. But what they're doing here is they're doing something very similar to what I was doing, except they're using little line segments. So they're drawing lines between. Well, first they're taking. Okay, you drew. Here, hold on a second. I can do this semi-visually here. So they're saying, okay, here are these points. We're going to create a spline, kind of a curve that goes through all these points. And we're going to interpolate new points along that spline. And then we're going to do the same kind of like velocity-based pressure algorithm. And then we're going to draw lines between each of these points. Well, that's not right. And we're going to make those lines thicker for the parts that are thicker and thinner for the parts that are thinner. And the problem with that is that you get these kind of like strange moments in between. This is doing pretty well, but this is like the state of the art for like how do you solve this problem. If you Google how do you do pressure sensitive variable width lines in Canvas, you're going to find either stuff that I wrote or stuff that tells you how to do it this way. I think there are a couple teams like GoodNotes, for example. Like, I still don't know how they're. I wish I knew. I think it's globs, but it's not open source. And so if you're working on open source, you have very, very few options. And so, yeah, that's it. I kind of do like mostly Twitter-driven user testing. I share a lot of like example builds, for example, the preview builds, etc. No, I would love to. Yeah, no, yeah, this is one of those projects that's very hard to kind of quantify success, and so I just use my own judgment as a accredited artist to say this is right or this is wrong. But I get a lot of feedback, contributions also on GitHub. It's open source again, like it's not a very big library, so it is something that you could work on. I think that's time, right? That's time. So thank you.
So everyone, can we get a big round of applause for Steve Ruiz? We'll take a break of a few minutes. There's still plenty of pizza and beer over there, and the toilets, you just go all the way down to the end and then turn right through the door. See you back here in a few minutes.
Feelings are sore.
Okay, welcome back to the second half. We have another great speaker for you here, Seph Li. Seph is a generative artist. He's born in Beijing and has been working here in London for a while. He's exhibited across the globe for the last 10 years, done lots of cool shows. He's going to tell us about one of his latest, or the latest, I think, projects called Phase. It's a really cool project, blends data from Wolfram physics with a kind of underpinning of Chinese-inspired art and philosophical elements. I'm going to let Seph do a much better job of explaining what it is, but it's a lovely project, and I'm quite excited to hear about it. Everyone, please give a warm welcome to Seph Li.
Thank you, everyone. So my name is Seph Li, and I'm basically working in the realm of media arts and interactions. So here's a video of some of my previous works. So usually my works basically includes an interactive system that I define the rules. And there is usually some simulations that blends all the visitors' input into the system and run the simulation and output into some procedural graphics. And I also do some 3D printed sculptures, something like that, but this is still data-driven. And also, as you can see, my general aesthetic is largely inspired from traditional Chinese landscape paintings. And this is the piece I'm going to talk about today. It's called Face. So this is a screening just happened last month in Shenzhen. I got really lucky to show my piece on this 30 meters tall outdoor projection area. It's the hugest one I've ever seen. So this piece features a generative system that uses the rule sets from the Wolfram physics project and generate a universe clusters that blending the pure data form and the landscape painting style into one piece. Here's the, it's a bit washed out, but this is one of the output from the system. So I'm going to talk about how this all started. So I got this idea last year, basically because I got 2 exhibitions and 2 commercial commissions canceled because of COVID. And then suddenly dropped from really busy to had nothing to do. So I started reading around about finding new ideas that could evolve into some new pieces for me. And then so Stephen Wolfram is a mathematician and the physicist. So if anyone been using Mathematica, you have probably heard of him. He made the whole Mathematica, which is the kind of the mathematical rule every mathematician has been using nowadays. So he made a blog post, not some real paper, in April last year, which he claims there's a system that if you iterating through a simple rule set, it will eventually grow into a really complicated graph. He called it hypergraph. This hypergraph, he analyzed it could represent something for the space-time and also the causal relationships that could resolve our long idea of the universal theory of everything. And as a side note, he is actually the student of John Conway, who is the father of the game of life. So there's no surprise he's been developing this kind of system for about 2 decades, and he finally concluded this is the thing. He thinks there's a potential that we may actually find the computational nature of our universe. And I'm going to explain how trying to simplify this process so everyone can understand how this works. So imagine we got a graph, which is got 3 nodes and 2 relations, which is x to z and x to y. And we also have a rule set, which says if we got a relations xy and xstat, it will evolve into xstat, xw, yw, zw. So if we apply this rule to this graph, then we can evolve this graph from x to y, x to z to x to z, x to w, y to w, and z to w. So the theory here is very simple. It basically says if we iterating through this simple process, then this hypergraph will eventually evolve into something interesting. So we take, so this is the result of the first step. So let's do this again. So this was the result we just got here. And if we do this again, so we can say, so the first one was the result from last page. And then we do it again, we're going to get that one. And after a few iterations, we're going to get something really complicated and starting to look something like a universe structure. And this is the result of the example rule set after 40 steps. So it starts to look really interesting. And here's a few other examples of some other rule sets. And as we can see here, some of them tend to look like a 2D graph, which is the one up there. So it definitely doesn't show any structure like it can live in 3D space, while others may have looks like a 3D, and some of them are more spiky than others. So some of them are looking really smooth. So I'm not going to go into all the details of how Wolfram did the math, but he basically claims this spikiness he expanded as the curvature of the universe spacetime, which is in line with the theory of relativity, which describes how smooth this space-time can be, or how if it's really spiky, then that could be there's a really heavy object in that area, which distorts the space-time around it. And he also got a theory of using the kind of number of points and the number of relations. It can deduct into some kind of a mathematical dimension, which we like, just like in our space, in our universe. But he also admits that with all the rule sets has been trying out for the last 2 decades, there is nothing like our universe. So he's still trying. If you look at his website, he got a new thing called the Wolfram Physics Project. There's currently, I think there's about 6,000 rule sets he's been playing around with, and that project is still going on. Might be one day he actually found some rule sets that are really similar to our universe. I just talked about how this can define the space and maybe the gravity, and how this can lead to the famous theory of parallel universes. So here's an example, because when we look at this rule set we're using, for each step is doing the iterating thing, it could evolve into different results. So the bold red lines here is the new generated lines every step, and the dashed ones are the ones to be removed. So if you look at the third graph on the top, so here we're actually removing this two, which matches the rule set, but we could also remove that two to start with. And this will potentially give us different results. So here's a higher level graph. We can say this more clear. So it's the first graph will have 2 choices to grow this graph in, and that accidentally looks the same. But the next step, this graph has 4 different newer passes to grow in, and that one also has 4. And they will all have different structures. And next step, we will have more chances to grow into something different. And eventually, we can draw another graph that looks like this. And one interesting is, if we look one step back here, we can say even though this one step before, they have different intermediate results, but they actually came into the same result after a while. Wolfram claims if we apply this kind of theory into this growing hypergraph, we can deduct a causal relationship, which is the big foundation of our logics. We know there's something happening, and they may going through different process, but will lead to the same result, which he claims is one of the foundations for our logic, for our universe to exist. And so here's the kind of the rough explanation of his theory. I recommend if anyone's really feels like this is an interesting topic, you might want to read his blog post. It's really intense and very interesting. And what's really interests me of this theory is it's not really like a scientific hypothesis, because when we do science, we actually first observe the phenomenon, and then when we make some hypothesis that could make this phenomenon happen, and then we do experiments to validate this. And if we validate this by experiments, then we say this is the scientific rule or a scientific hypothesis. But what Wolfram was doing is a top-down theory. So he went from the very foundation rules. And so if we do this from top-down, then we might be getting to the phenomena we're seeing today. So, which is probably the reason most of the physicists and mathematicians thinking he is mad. The theory won't lead to anything, but still its concept is very interesting, and because it's top-down, and it's very familiar, very similar to the Chinese Taoism, which is we've had from 4th century BC, like 2,400 years ago, which we had a very old Chinese philosophy book that the Tao gave birth to 1, 1 to 2, 2 to 3, and 3 to all things, which basically says the ancient Chinese believe there's a rule coming from the sky, and it grows something from now, and eventually if we repeating this rule, and it will growing into everything we're seeing today, which accidentally just matches what Wolfram has said. So I found this kind of relationships really interesting, and I found there's might be a chance I could make a generative piece that combines this scientific hypothesis and the very old Chinese philosophy. And so I started making this piece last year, and I was also very lucky to get a digital commission by Chinese Arts Now last year to actually make this happen. So, as I just said, there's a few challenges were the things I wanted to do with this piece. So first is the Wolfram project actually has data for each rule set, but it doesn't provide data step by step. So if you input the rule set and say you want to say how this graph looks like in 40 steps, then you can query this result. But because of how they only care about the result, like how it's being visualized. But if I'm going to show this process, then I need to place this nodes like step by step, and the node's position can't be changed, like what Wolfram is doing in his software, which means I need to write this algorithm my own. The next one is I do want to use the Chinese ink painting style, which I'm familiar with, and I think is a good visual cue for the visitors that they can tell this is something Chinese at first glance. And the third one, because it's still COVID last year, so I had the challenge of this needs to run on everyone's browser. It can't be an offline piece. And the next one is interactivity. So here's an interesting concept, because I just talked about this Wolfram theory actually can produce parallel universes that shares the same structure, but they are different. So I had the idea, like, why don't I make this thing running in your browser just on its own? And when you observe it, it actually does the thing in quantum physics, which result in the collapse of the quantum state, and all the parallel universes will be gone. and only one will be left, which is the one we live in. So that might be something interesting as a, like a killing interactivity to attract people, because it's still an online piece. I don't want people to just stay in front of their monitor and watching something they might not even know what's going on. So that might be a key to really attract people. And the last one is, I still do very care about the concept, how it's being conveyed. So that's another challenge. I do want the audience to know what it is. So this is the thing I just talked about. For the last one, I decided to add some progressive text, because while I'm calculating this structure step by step, I can know whether this step there's a new universe being born and there's something interesting happen. So I added in progressive text. So people can follow what's going on in the graph, like step by step. This is the result of the version from last year. I think it looks pretty good. And there's a video. I'm gonna skip this a bit to say. So you can say how this goes, like in action. And for the interactivity part, I decided to use the ultrasonic signals. So if you can sense the ultrasonic signal from your phone, and the speaker on your laptop or desktop will pick it up, and then triggers the collapsing of the universe structures. Here's some other results from the system. I think it generally delivered my expectation from last year. And this is the link to the online version. You can still play with this. So one thing is I actually didn't have very long time developing this piece. It's because while I started working on this, and I suddenly got a few commissions coming in, and I had to struggle my time balance between this one and my mandatory project. So found out there's a few problems with this piece. The first is because I'm allowing actually a maximum of 8 universes to be appearing at the same time in the online version, but I'm actually using the same placement algorithm. One issue I didn't realize is we're lucky, and this rule set actually be iterating more than, say, 40 steps and then growing some really complicated structure, and it's starting looking very similar because each universe are using the same algorithm. And normally, they just starting to look like a sphere, really complicated, and you can't tell which universe is which, and it just look like a sphere, all the same. So that too is the kind of examples I can't really tell like there's any differences between them, and it's just not interesting if you start looking at it more than like maybe 4 universes. And the right one is actually the pure data structure without all the rendering things, and you can tell it definitely looks the same. So the thing first I want to resolve is I need a different placement algorithm per universe, so they can look like a different, and people can say, oh, I know there's something new is happening. Beyond I have to look at your text telling me this thing is happening. Second one is we did some user feedback, and a lot of the audiences we heard is they thought there's too many things going on, because there's Wolfram physics, mathematics, quantum physics, Chinese ink, Chinese Taoism. What the fuck? I mean, there's too many things. Each piece needs time to digest, and there's impossible for audience to grasp them all in maybe 2 minutes time of watching this universe to evolve. So that's the second thing. I need a clear visual clues to tell people this is this and that is that. So I think I was relying too much on the text. And there's a bit of throwback to some of my learnings from my previous piece. This was actually my final project at UCLA 9 years ago. So it was a sculpture with a Pepper's Ghost pyramid in the center. It's actually an interactive piece. So you actually needs to go close by to the sculpture, and then the boy, which is trapped inside the pyramid, will start to reacting to you. And if you go one more step, if you start to blow your air to the pyramid, where it touches all the sensors at the foot of the pyramid, it's going to trigger the next level of interaction, which will actually show your warmth to the boy, which give her the strength to step out of this pyramid, which represents his inside world. And it didn't work well because there's no tips and there's no entry point. And people watch, oh, this is sculpture. And then when you close by, then the animation changes. They thought that's it. So they stopped there. And they didn't expect there's another level which could really give them a climax, because it's a fun art exhibition. And people doesn't, not every work is interactive. So people doesn't get the background or the clues that what they're supposed to do. So the findings from this one was artworks were primarily interactive artworks. It needs an entry point, especially there's a layer of storytelling. You need the audience to know at first glance what this is and what you're expecting them to do. And next one is, I came across this painting some while ago at Tate Modern. So the painting itself is very beautiful. It was done by an American artist back in the 90s. The problem was the wall text. So in the wall text, I didn't take a picture, but I remember what they say is, the artists said in Chinese landscape paintings, yin and yang, which we refer to the darkness and brightness, she says that she thinks the yin represents the water, usually black in Chinese landscape paintings, and the yang represents the mountain, which is usually the brightness. So he thought it would be interesting to flip them, so he used a wet paint to paint the waterfall. It sounds really, really interesting, except it's absolutely wrong. So when we say yin and yang, we do mean brightness and darkness, but when we refer to the landscape, it means something completely different. When we say the yang, which is the brightness, which literally means the south side of mountain, which is where the sun sets it. And yang, when we refer it to the water, it literally means the north side of the water, because it's usually lower down, and the north side is the one side being bright up. And it unfortunately has nothing to do with landscape paintings. We don't use that concept for painting. So the learnings here is cultural translation difficulty is real. Even professional curators and artists get it very wrong, even though it sounds interesting. So that's another thing I want to avoid. I want to be more specific instead of giving people a broad concept that people can imagine on its own. It might be interesting for the audiences, but I want to keep this concise as possible. So to summarize, there's just 3 things I want to do. First is the better graph arrangement algorithm, and better entry point, clear cultural references, and keep the elements essential. And I was also very lucky. I got a grant from Arts Council England this year, so I can continue the R&D on this project. And there's another funding because the last version was done with WebGL, with 3GS, and there's some technical limitations I wasn't very happy with. So for this new one, because I'm gonna make it into an installation, hoping COVID can end and there's gonna be an offline exhibition. So I moved the whole thing into Cinder, which is a C++ kind of creative coding framework. And to start this new experiment, I kind of take a step back. So I went back and to imagine what if there's no Chinese elements, if it's just a pure generative data art piece in pure digital form, what it could look like if it just represents the universe. Then I get to this. So I discarded all the, the style, the looking, and it's just a pure data form. And I tried to get the different universe graph arrangement algorithms for each one. So there's another one, I think it's a bit more clear. So when the new universe is born, before in the last version, they are actually born at the same position. So they are definitely overlapping. And for this one, actually calculating the trend, have a parameter for like the general direction of which this universe, which direction it should evolve into. And when I generating a new universe, I got a manual offset from the last one. So it looks like they are colliding, but they are not the same. They are trying to grow into different directions. And then I showed the field of this to some of my friends who I never told them about this project. And some of them reported back, oh, that just looked like a few universes colliding with each other. So I think that's first the mission complete. And then after this, I think I'm confident to think how I can add the Chinese visual elements back in. And I start to look back in history. So this one was one of the most important landscape painting in Chinese history. It was by Fan Kuan. It's called Xishan Xinglü Tu, which literally means travelers in Xishan. It was done in the Song dynasty, somewhere in the 10th to 11th century. So why this is important is it doesn't use any new colors or new techniques to paint, but what is important is set up the scaling, the fill of the space for the ink painting. So because in Chinese landscape paintings we have no perspective or perspective everywhere, so it literally paints a small amount of area, which is the one we are actually seeing by our naked eye. And when we paint the huge mountain in the back, we actually imagine we're moved away from those smaller or the close areas. We're standing back somewhere really far away, so we can look at the big picture of the mountains. And this painting just invented a new way that they can be layered together to show this whole kind of imaginative understanding of the space in the landscape painting. So I had this idea, so if the traditional artists, they be able to represent this and their understanding of the universe by a landscape painting, why can't I? So I started to think, why can't I borrow elements from the landscape painting directly and use them to visualize each universe? But before that, I came across another artist, which is Wu Guanzhong. He is also one of the most important landscape painting artists from last century. He actually studied in France, I think back in the 60s. So you can see his paintings have a blend of the traditional Chinese ink and the Western kind of style of the bold color and the strokes. So what I like is just this kind of very sensitive blending, this feeling where he uses bold stroke and a very different visual representation for different elements. So you can see when he paints the rocks on the mountains and how he paints the waters around it and how he paints the landscape, they all use the different stroke techniques. So I got inspired from this. that's the result of my own implementation. So what I got from, I used the 4 elements inspired from landscape paintings. This is water, and this is the mountain, slightly trees, and this is sky. And the black there is the shadow. So in this kind of setup, I discarded the whole idea of universes colliding with each other. I tried to blend them into the same one, so all the universes available in this graph been combining themselves into one single painting instead of splitting their identities one by one. So I was pretty happy with this result, and then I have the next problem. How can I put them together without looking like too weird? So here's another cultural reference, which is the bagua. Back into the yin and yang thing. So this is the correct one. We do use yin and yang in here. And the yang, the bright one, is actually being used at 0, and the black is 1. It's actually a binary counter, and the whole thing is an octal counter, which actually, luckily, it was also originated from Dao De Jing. So back in the circle, I actually used the same reference in the culture, so I was very happy that I didn't look like I was trying to put things together, like with no good reason. The result we've just saw is very brute force, black and white put together. So here's a few more results from the system. It's definitely a bit washed out. Not sure if the color space was different, but I was generally very happy about this because, as you can see, it generally, even though all these results were, I think, 50 steps, but they all have very different shape and structure, and they, you can definitely feel there's an intention of they trying to blend something completely different, and that I think drives the audience to get to know what's this idea behind. And they start to read about the concept of the Wolfram physics, and then and the Taoism, I think they can get back to this painting, they get it. Okay, this is the intention from artist. So this is basically a reverse process. So in the last version, I tried to do the text kind of approach. So trying to teach the audience from the very beginning alongside with the visuals. And now I kind of discarded that idea with just trying to use the visual to impress people and instruct them to know there's something colliding or contradicting to each other. And then they can start looking at the background story of the piece. I think this is more in line with usually what we do at the museums, where you look at the piece first and then you read the wall text. Also, since this is a creative coding meetup, I don't want to talk about all the design process and bore everyone away. So there's a few technical takeaways. So when I was saying, I wasn't really happy with the WebGL implementation because it got a lot of transparency in the lines, and they can't blend properly on WebGL. The reason is, when I was generating lines, I only got the starting point and ending point, and all the curves or the shapes between it was actually done in the vertex shader. So if I was trying to sort this by object level, I only know the straight line. So there is no way to get it perfect, sorted on object level. Also, the lines are intersected with each other, so there is no way to do that properly. Then I started looking into this order-independent transparency implementations. This is the simplest one I found. So in theory, if you do a fast Fourier transform and sort that in the fragment shader later, that's the perfect solution. But the reference paper I found was more than 20 pages long. And I thought it probably doesn't worth it. And so I found this GDC talk was implemented in the game called Agents of. So it's a popular technique called depth splitting. It basically calculates for each transparent pixel, it calculates the depth from camera to that pixel, and it generates the weighted table as a buffer, which, if you want to read the code, it's the second to the last line there. So visually it looks like this. So it's generated accumulated weights data and accumulated weighted color. And when you do the final blending, you just subdivide those two and give you a correct blending result, which is this code. But again, if anyone wants to look into how to do a fast and cheap, good-looking order-independent transparency, this is the one I recommend. Another thing is, I was looking into adding some instant feedback to the interactivity instead of everyone has to, because it's going to be an offline exhibition. So I don't want everyone have to wait for maybe 1 minute or so to watch the universe grow into something so they can collapse it and look like the end animation. So I want something instant. If you start to interact it, there's some immediate feedback on screen tells you this is the interactive piece. So the thing I did was this laser effect, which just draws through the transparent elements of the graph. And how I did this was thanks to Cinder and native OpenGL. I have access to compute shaders. So while I was rendering the graph, I generated a whole voxel space, like a cube, like tightly fit into the whole bounding box of the graph. And while I was drawing each transparent pixels, I actually also draws into that voxel buffer of where each transparent pixel is. And then I use another compute pass to do a simple refraction passes to calculate the actual laser pass, which is displayed at the right-hand debug panel there. All the refraction index was randomized. For some reason, I felt it looks more interesting than the correct one. The last technique was there's something I didn't know about that actually exists in OpenGL, that you can store a bunch of a shader buffer object into a linked list, which is the side effect while I was researching the order-independent transparency. So there is a legacy implementation. Is you can, when you do the transparent, you can actually write a transparent node of each pixel into a linked list. And when you draw it, you actually sort out that linked list in the fragment shader to get a perfect transparency, which is not practical at all because it eats up all your memory. But it is interesting if we want to capture this whole graph with particles, with perfect depths. And I used this technique in the final collapsing animation. So I probably need to play this back again. So watch this, the center one. So in the final bit, it kind of turns into particles and drive up. That was actually done with turning that whole graph into a particle. And that whole thing can just move freely. I wasn't go too crazy of that because there's already many things going on the screen at that time. And yeah, I think this is all. And also, thanks everybody here, and thanks for Chinese Arts Now and Arts Council England for the grant to make this happen. Thank you.
Thank you very much, Seph. That was a wonderful talk. Pretty cool. So just a public service announcement. If anyone thinks that the maths of alternate universes behind that is really cool, then Wolfram, the guy who came up with it, is a wonderful hour-and-a-half interview between him and a physicist called Sean Carroll. This is one of the most mind-bending and wonderful conversations I've had, and it's available for free at preposterousuniverse.com. So that's Sean Carroll's podcast, and it's if you want to learn more about this math, it's just a conversation between two ridiculously smart guys about stuff that you really have to focus all the time to try and understand. You'll still miss half of it. So if that sounds like fun, then preposterousuniverse.com. Okay, we got some time for questions. Does anyone have any? Cool. Well, I've got. Oh, we got one over there, but since I already started, I've got a question myself. Now, I understand that if I understand correctly, these universes are made up of lots of points, and the points, if I understand correctly, have relations to other points, but don't, from Stephen Wolfram's algorithm, have a position in space. So you presumably have to decide as an artist how you're going to render these. So how do you, given all these like graphs with relationships between nodes, how do you just how do you lay them out so they look like they do on here?
Yeah. So. I mean, go back to the first version, this one. So this indeed was a very challenging topic because if we're lucky, like some graphs has a nature structure that it all grows from one point, which we can say something like the top two, which you can say is a clear different structure. But normally it's very sparse, like a very sparse graph. And so this is why in the first version I generally got a bit of like a randomized approach, where if I got a new relation growing from an existing point, then it just randomized pick a direction from this point and calculate all the relations already linked to this existing point and how long are they, like the lines, how long are they, and get a average. And also apply a bit of randomness and directly extend that one. So that's the result in the first version where it kind of looks like very similar after a while. Next one, forgive me. So in the newer version, so you can see, let's take the top left one as the example. This one, I intentionally make this more like a grid. It's always growing, trying to follow a grid, and also the visual is more like something flowing from one side to another one. So this was intentionally done. Like when I was calculating the relations, when I need to check this existing point, where the position of its existing relations, and also what's the general growing direction of the graph. And I can't remember the detail, but it actually calculates which the one it's trying to follow the general direction, but not the very already dense way, and trying to spawn the new point along that line. And if it needs to be placed very far away, that's fun because it's great. And I kind of have a separate algorithm for other ones, because the one on top, the bright one, I had the idea of making it more like a sailing, like sails. So it's always trying to follow one direction and wrap it around. And so so in the wild, it kind of looks like something like my hair in that direction.
Cool. Okay, so you've got like a bunch of programs, each of which take the graph and sort of render it in a style unique to that program.
Yeah, so it's generally about a trial and error.
Cool. Oh, thanks. Another question over here.
You mentioned. You mentioned if obviously you can't exhibit this in person at the moment, right? If you were going to, how would you put these into an exhibition in physical space? You know.
I actually don't have that rendering on this machine, but I had an idea of a kind of circle glass panel, and maybe this tall, and there's a rear projection from behind. And I imagine I can make a small device like a desk, so people know you roll it, and once you pick it up and move it, then the laser effect kicks in. And if you make it really like a hard interaction, like it's just rolling it on the ground, then it will trigger the collapse of the universe system.
Cool. Thank you.
Any more questions?
Yep. Thanks for the presentation, and actually follow-up question to like exhibition and how to make it interactive.
Yep.
If one person has to dodge, how about multiple people? Like, how could we have any ideas how to make it more participatory with groups of people, for instance, to create multiple universes?
The idea is that it needs to be a linear experience because there's a bit layer of storytelling. So from my experience of my previous work, I found it's nearly impossible to do a uncontrolled interaction with storytelling elements because it's just not linear. And you can't make sure everyone starts with the beginning of the story. And it just breaks the experience.
Thank you.
Okay, well, thanks very much, Seph Li, for a wonderful talk. Yeah. Okay, that's the end of our program for this evening. We have an area booked at the Long Arm pub round the corner. I believe Z is, where's Z? There you are. Is going to lead people there, and then either Anthony or myself will be taking another group later. So do follow along, and look forward to seeing you there. Thanks very much for coming, and thanks again to our sponsors and to Huckletree for giving us this wonderful space. Cheers.